In order to find a line equation, there are generally two formulas that are used. Both of them involve the concept of rise over run equaling slope. Now you see in the diagram I've got here, I've got one general point, A, which is xy, and a fixed point. In mathematics we often use subscripts. There's x1, y1 to designate a fixed point there. So if I use the points A and B, y minus y1 is the change in the y over x minus x1, which is the change in the x. And I put that equal to m, which is the symbol that we generally use for slope. If I multiply both sides by x minus x1, sometimes called cross multiplying, I get this formula, which is referred to as the point slope formula. It's called the point slope formula because there's a place here, the x1, y1, for any point on the line, and m, the slope. On the other hand, if I use A and C, again the general point, and C being the y-intercept, 0b, this time I get y minus b over x minus 0 equals the slope m. I can remove the 0, and again cross multiply both sides by x, and I've got y minus b equals mx. Once I move the b over, I have the familiar y equals mx plus b, the slope y-intercept formula, which is generally the first one that students learn when they're in grade 9. Now, let's take a look at how we can use those two formulas. Here's a sort of a typical equation. Find the equation of the line passing through A and B. The first thing we do is figure out the slope. 7 minus 1 is the difference in the y's over 1 minus negative 2, which is the difference in the x's. And once I simplify that to 6 over 3, I get a slope of 2. Now, if I'm going to use the y equals mx plus b formula, the first thing I'm going to do is put in the 2. Then I'm going to use either one of these points. It doesn't matter which one you use. I'm going to use 1, 7. I put the 7 in for the y and the 1 in for the x. And once I simplify that, I get a value of 5 for b. And my equation then is y equals 2x plus 5. If I want to use the other formula, which is y minus y1 equals m bracket x minus x1, I have a place for the point, and again I'm going to use 1, 7. I'm putting the 1 and the 7 in for the x1 and the y1, 2 for the slope, and then all I have to do is simplify. Multiply the 2 into the brackets, move all the terms, take this negative 7 over there is plus 7. I'm going to leave the y here for now, and I can then get this equation in the y equals mx plus b form. Now I'd like to look at one more example. This one is a little more difficult because I'm giving a fraction for a slope, being 5/5. If I use y equals mx plus b, there's my slope in here, 4/5. I've only got one point this time because we were given the slope. So I put in the 2, 3, 2 for x, 3 for y. Have to multiply this out. 4 times 2 is 8, so I get 8/5. I want to move it to the left side to solve for b. Get a common denominator for the 3. And b equals 7/5. Now once I put that into the equation, you see I've got most of it here. All I have to do is put in the b now, 7/5. That's the equation in the slope y-intercept form. If you want it in standard form, you have to multiply through by 5. That's multiplying every term by 5. And then I'm going to move the 5y to the right hand side to get it into standard form, which requires the number in front of the x to be positive. And that's developing the line equation using y equals mx plus b. The other formula, y minus y1 equals mx minus x1, I have a place for the point. I can put in the 2 and the 3 for the x1, y1, and here's my slope, 4/5. I can immediately get rid of the fraction by multiplying everything by 5. See, this becomes 5y, this becomes negative 15, and I lose the 5 over here because I'm multiplying by 5. Multiply the 4 into the bracket, then move the terms around. I've moved the 5y over as negative 5y. The negative 15 over is positive 15. And that's my equation then in standard form. It's a lot easier to get the standard form using this particular formula rather than the y equals mx plus b formula. If you wish to have this in the y equals mx plus b form, simply move the 5y to the left side and divide everybody by 5, and you're now in the y equals mx plus b form. So you can use either of these formulas anytime you're trying to develop the equation of a line.